Good morning. This is your Stat Sensei, Mr. Spensei, and this is Lost Keys for a Professor. So, a certain professor has 8 keys, but he never recalls which one fits his office door lock. So, he places all of the keys on a table and randomly selects and tries one key at a time. So, we have a bunch of keys, he tries a key. If the key does not fit, he places it back in the original pile. He pastes it back in the original pile. If he does that, he doesn't know which key he tried already. And then he randomly selects another key. So it also has a note. All the keys look the same, and he's unable to tell you which key he's already tried. Conduct a 14 trial simulation and answer the following questions. All right, so a 14 trial simulation. So that means we're going to have to do this 14 times. Okay, so what is the question? Well, we need to find out how many keys he has to to find the one that opens the open door. How many does he have to try? How many keys does he have to try in order to find the correct key to open the office door? All right. So we got to figure out how many keys he has to try. So the success, finding the key to open the office door. The component is testing the keys. We're going to do 14 trials. Duplicates are allowed this time because he puts them back into the pile and can't tell them apart. All right. This is how we know that duplicates are allowed. It's not a percentages, but it says all the keys look the same and he's unable to tell which one he's already tried and he keeps putting them back into the pile. Okay. Well, the model. First off, how many keys are there? All right. Well, basically, we have a random number table. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are our numbers. All right. So in this case, we define key 1 as being the right key. That means 2 through 8 are the wrong keys. But what about 9 and 0? Well, 9 and 0, we don't even need at all, so they don't count. So 9 and 0 are just plain old skips. All right. 9 and 0 are skips. We don't need them. Yes, they're going to show up on the random number table, but we don't need them. So beginning from left to right, and we always begin from left to right because that's what we read, I would select 1-digit numbers, and we can use 1-digit numbers because it's just 1 through 8 until I find the correct key. I would count the number of ones until the correct key, number of numbers of 1 digits until until I find the correct key, until I find number 1. All right. So really important. So we're going to count the numbers of 1-digit numbers until the correct key is found, which in our case is number 1. And we're going to do this 14 times, and then we'll take the average. All right. So normally I like to start each trial at a new row, but I don't have enough, so I have to continue. So here we go. First trial, 6, wrong key, wrong key, wrong key, wrong key, right key. So I circle it. This is the end of my first trial. This is trial 1. In trial 1, I had to open 1, 2, 3, 4, 5. All right. Because I don't have enough rows, I'm going to start the next trial right after that. Okay. So, and I can do that because it's a random number table. So here we go. 7, wrong key. 8, wrong key. 5, wrong key. 5, wrong key. Hey, that's a repeat. But remember, repeats are allowed because he puts them back in the same pile. 8, that's a repeat, but it's okay because we put them back in the pile and can't tell them apart. 2, 5 is the wrong key. 9, we crossed 9 out because 9 is a skip. It doesn't count. Because remember up here we said it's a skip, so it doesn't count as a key. And then we have a 6, and we finally get a 1. So we count them up. 1, 2, excuse me, 1, 2, 3, 4, 5, 6, 7. Skip that key, doesn't count. 8, and then our ninth key And so we write a 9 up here. It took us 9. We had to try 9 keys. All right, the next one starts off at 0. Remember, 9 and 0 are skipped, so it doesn't count. 7, 6, 1. Oh, I had to try 3 keys. In this case, we started off as a 0. So this 0 doesn't count. All right, so 7, 5, 4, 6, 4. Remember, repeats are allowed. 8, 5, 3, 2, 6. And we keep going, we keep going. Oh, this 9 doesn't count. 8, 4, 0 doesn't count. 2, 4, 3, 7, 1. So that counted. So here we go. 5, 10, 15, 16, 17, 18, 19, 20, 21, 22. I think that should have been a 22. I think that's a mistake. So let's try that again. 5, 10, 15, 16, 17, 18, 19, 20, 21, 22 keys. Then we're going to have to, then we go to the next one. All right, so that's the end of that trial. We go again. So this is trial 2. This is trial 3. This is trial 4. We're going to go, oh, 0 doesn't count. We don't care about repeats. Repeats are permitted. And this is trial 5. And we had to go 1, 2, 3, 4, 5, 6 keys. Then we go to trial 6 because there's the 1. And once again, repeats are allowed. 9 doesn't count because 9 and 0 are skips. And we have 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Did I miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 keys. Now this is where it gets weird. We're going to actually start this next trial right here. Okay? So trial number 7, there's a 5 and there's a 1. So that's trial 7. It took us 2 keys. Trial 8, hey, we got lucky. It only took us 1 key. Then we have to go to trial 9. Trial 9, I'm looking. There's my 1. So trial 9's right there. 9s don't count because it's a skip. 9s don't count. 9s don't count. 0s don't count. 0s don't count. 0s don't count. 0s don't count. Let's count our numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 keys. So I had to try 20 keys for trial 9. Trial 10, just 1 key. I'm looking for a trial. I'm looking for a 1. Here it is. So in this case, 1, 2, 9 doesn't count. 9 doesn't count. So 1, 2, 3, 4, 5, 6, 7, 8. Let me try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 keys. Then this is trial 12. It only took 1 key. Here's 13, and we have 0, 0, 0. Those don't count. The 9s don't count. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 keys. And we're down to our last trial. Well, 0s don't count because they're skips. 9 doesn't count. It's a skip. 9s, 9, 0, 0 is looking for a 1. So this is the end of the 14th trial. Well, how many numbers do we have to take? And remember, we keep counting repeats because it says repeats are allowed. So we have 2. So that's 1 number. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 numbers. All right. So we've run our 14 trials. And this one had 5, this one had 9, this one had 3, This one had 22. This had 6. This had 11. This had 2. This has 1, 20, 1, 10. Here's another one with 1. I know I wrote 11, but 15. This is 17. All right. So we do have a typo here. So trial 1 took us 5. Trial 2, 9. Trial 3, 3. Trial 4, I'm going to recount those and make sure I didn't make a mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Ooh, maybe I did make a mistake. That'd be good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16, 17, 18, 19, 20, 21, 22. 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23. Ah, that is a 23. That's good. That's a 23. All right. So I made a mistake. That's a 23. So this needs to be 23. Trial 5 had 6. Trial 6 had 11. Trial 7 had 2. Trial 8 had 1. Trial 9 had 20. Trial 10 had 1. Trial 11 had 10. Trial 12 had 1. Trial 13 had 15. And trial 14 had 17. And that added up to 124. Well, 124, remember, we're dividing by the number of trials, gives us 8.8 keys. So based on the simulation above, in the long run, we would expect to have to try 8.8 keys in order to find the right key to open the door, which in our case happened to be key number 1. Now, once again, I want to point out to you guys, if it's in red, it's part of the sentence stump. So it says, based on the simulation above, in the long run, on average, we'd expect to have to find or try 8.8 keys in order to find the correct key to open the door. Okay? All right. So that concludes that video. Appreciate you watching. Hope it helped and sure like to see you on the next one. Thank you.